Okay, so today we're doing sum and difference identities. Don't let what you see scare you. It's not that crazy. I just wanted to show you that these did not come out of just somebody making them up. It's actually proven. And so if this is the work that has to be done in order to prove and come up with these formulas. And one of the things is that they're very valuable and make our life easier, even though it doesn't look like it's easier. And so here it's just saying so that you understand the sum difference. I'm not expecting you to understand all of this. I mean, if you do, wonderful. But it's a lot of algebra on there. And so if you look at this, if you have an angle, a standard position angle, like this angle right here, X on there, and you have this angle right there, and then you have this angle right here, which is standard position Y, that there is an angle that I could subtract the X and the Y from, and that'll give us the blue angle from the standard position blue angle right there. So if I subtract the whole thing is X and I subtract Y, that's how much I get back. But it's also the same thing that if I subtract, I have this whole thing is X and I subtract this Y, I am going to get the angle from Q to S. If I subtract Y from this one, I get, if I subtract Y from that, I get R to P. That's the first one that we talked about, that angle. And then if I subtract it the other way, I get the Q to S. So that really means that the angle made by the arc QS and the arc made by RP, they're exactly the same. And so therefore the chords are also going to be the same. And so that's what this is saying, is that RP is equivalent to SQ. So these two chords are equivalent. And so then using the distance formula, we get this, all the sine, and then using the Pythagorean identity, because it's cosine squared, sine squared, it doesn't matter what the angle are, as long as the angles are the same, you get that to equal to 1, and you have it here twice, and so that equals to 1, and then we do some algebra, and this here gives us the difference of cosine, and this one here gives us, once you put in, use this formula and put in a positive, so a negative, because a negative and a negative, you fill that out and you get that there. And here, notice how we're using that sine is odd, so sine of a negative angle becomes sine of a positive angle, but the sign switches, it becomes a negative sine y. And so that's what gives us the difference identities for cosine, so the plus and minus, and the sum identities for cosine. And then we know, because sine and cosine are cofunctions, that if I were to write it, sine of theta is equivalent to, it's just been a shift of pi over 2. Remember, sine and cosine are the same. It just has one shift. So this is what we have here. So that explains that they're equal to each other. And then we do sine of theta, which is this theta right there. And then we do the cosine, and then again the theta, and we put it into this formula up here, and we fill it in, and we know that this is also still equivalent to the sine of x because it's been shifted 90 degrees, and then same thing here, it's been shifted 90 degrees, so they're going to be equivalent. So now here is the sine, the sum formula for sine. And then we do the same thing again. Notice that we're using that cosine is even and that sine is an odd function, so that we get this, and this one here just becomes the same angle. And so we have sine of negative x is there. And so we get the sum difference there. So that's really where they come from. Do you need to do all that? No. But just know that these are the formulas that we have here. So from here, we end up getting that these are generated from doing all that wonderful trig there. So these are the ones you're going to need to know on there, and it's not that bad. There is a pattern. Notice that the sine has sine of the first angle, cosine of the second angle, and then they switch, cosine of the first angle, sine of the second angle, and same thing here. They're both the same, except for one is positive and one is subtraction and one is adding. And then for cosine, They're both cosine of the first angle, cosine of the second angle, sine of the first angle, sine of the second angle, and then they're the same thing. And then for tangent, they follow the same pattern. Tangent of the first angle plus tangent of the second angle. Notice how this is plus. And then this one here is going to be minus. So it's going to be 1 minus tangent of the first angle, tangent of the second angle. And there's a plus there. And same thing here. The only thing is the same except for they switch. So the main things you need to remember is that cosine, this is a plus, this is a minus, this is a plus. I'm sorry, that's a minus, that's a plus. And then for tangent, same thing. It's on the top, it's on the top. This one here, it's on the top, and then the other two are the opposites. And sine does the same thing. If it's positive, it's positive. If it's negative, it's negative. And that's how you prove the, well, that's how you remember the identities. Okay. So let's do some problems on there. One of the things that you need to do, well, we'll move this down because we'll use that later. Okay, so let's use some identities and how we're going to use this. So let's do a problem that says a tangent of 165 degrees. Well, this one here you cannot do on your left hand, and if you're not allowed to use when it tells you to find the exact trig functions, what you want to do is actually do you can't put it in your calculator and get a decimal. You're going to have to do the exact trig function. So the way you do it is by using these identities up here. You don't even need a calculator for this. 165. One of the things is that we do want to go back to something that we already know. So the like 30 degrees, 60 degrees, 135, anything from the unit circle that you could do, you use your left hand rule for, then you could be able to do these here. That's what you want to convert the 165. So how many ways can you do 165? So I could say that this one here is equivalent to the tangent of 135, which I do know, plus the tangent of 30. So 135 plus 30 is equal to 165, and I know both of those angles. Or I could go to tangent of 210 minus 45. So either one you could do. So notice there are different ways to do it. 210 is one that we know. This one here is in the second quadrant, the third quadrant, and then 45 is in the first quadrant, but we're subtracting them to get 165, still gives you 165. This one is here is in the second quadrant, this is in the first quadrant, but we still know those angles. So either one you would use. So for the first one here, I would use this part, and then this one here is minus, so then you use that formula, but it's still the same. So let's use this one here. So when we have that, we end up with tangent of 135 plus the tangent of 30 degrees all over 1 minus the tangent of 135 tangent of 30 degrees. Okay. So what is the tangent of 135? So you do your left-hand rule. Tangent of 135 is equivalent to a 45-degree reference angle. And so when you do the tangents of 45, we get 1. But this is in the second quadrant. And when we do, all students take CAT, that one there gives us to be -1 because tangent is negative in the second quadrant. So we get -1, and then the tangent of 30. So you do the left-hand rule and you do the tangent of 30, and you get 1 over the square root of 3, but we change it to square root of 3 over 3 by removing the radical from the denominator. And then we have 1 minus, and then we do the tangent of 135. You already did that, so then you get -1 there, and you already did the tangent of 30, so square root of 3 over 3. And so then we need to, this is a complex fraction. We do not want a complex fraction here, but I'm just going to simplify it a little bit. So it'd be -1 plus the square root of 3 over 3 over 1 plus the square root of 3 over 3. 3, because that's a negative and a negative becomes a positive. And so we could get rid of the 3 by multiplying. This is a denominator of 3, 3, and this is a denominator of 1 and 1. So what we're going to do is we're going to multiply this by 3 over 1 and this by 3 over 1. And so what you end up with is when I distribute this to this part, I am going to get negative 3 plus, and then you're going to distribute the 3 to the square root of 3 over 3, but that's going to cancel. And then you're going to do the same thing, and that's going to be 3. You distribute that, that's going to cancel. So this real answer is square root of 3 over 3 plus the square root of 3. Not a complex answer. And so that's how you would do that problem on there. Okay. Let's talk about how do you do when it's not degrees and radians. I know that you guys freak out on that stuff, but it's just dealing with fractions, and that's where we're going to use this part right here. And so we know, this was the refresher on left-hand rule and knowing what those values are. And so filling that out and doing, the negative going, if you go this way, it's negative. If you go counterclockwise, it's positive. And so therefore we get that on there. But one of the things is that how do I figure out what to do if, say, for example, I have a problem that is sine of negative 5 pi over 12. So one of the things that you want to do first is that it's an odd function sine, so that negative is actually equivalent to negative sine of 5 pi over 12. You could do that on there. But now you have to use the sum difference identities because you want to find the exact answer. So in order for you to do that, you have to break up 5 pi over 12 into one of these that we know. Any one of these, the 5 pi over 12, anything in here and here and here, we have to break it up into that. Now that looks like it's really tough, but it really isn't on there. So if we look at that, we look at the denominator and it's 12. So we want to be able to look at, I'm going to do all of these. So we're going to say pi over 6, pi over 4, pi over 3, and pi over 2. Those are the ones that we're going to be working with. And I need the denominator to be 12. So then what you do is, in order for this to be 12, I multiply this by 2. So therefore I have to multiply that by 2. I need to multiply this by 3. I need to multiply this by 4, and I need to multiply this by 6 because I want them all to have a denominator of 12. So then this gives me 2 pi over 12. This gives me 3 pi over 12, 4 pi over 12, 6 pi over 12. So now they're all 12. So now I have them all being 12. And so now I need to concentrate in the numerator. So the numerator is going to be 5 pi. So what combination is going to give me 5 pi? And it doesn't have to be just one. It could be, there might be a couple that actually work to be 5 pi on there, or a different answer on there. But this one here, we want 5 pi. So this one here, 3 pi and 2 pi, that equals to 5 pi by adding those two together. So what I do is I change this to negative sine, and then I'm going to change that not to this part right here, but what it actually is. So, and it doesn't matter which one you put first. You could say pi over 6 plus pi over 4, because when I do that, I am going to get 5 pi. So that's the easiest way to do that. And so any of the problems that we have, they're always going to be some kind of combination using probably the first quadrant, but you might have to add or subtract on there. And then you actually do the problem. And so now when you do that, you're going to get negative, and then it's going to be the sine of pi over 6 cosine the first angle, cosine of the second angle, plus the cosine of the first angle, sine of the second angle. And then when you do your left-hand rule, we know the sine of the second angle is going to be 1/2. and then square root of 2 over 2 plus the square root of 3 over 2 times the square root of 2 over 2. And that gives us negative square root of 2 over 4 plus square root of 6 over 4. Now, with these radicals, you could multiply them as long as they have the same index. They're both square roots, not like the cube root and the square root. You can multiply the inside, but when you're adding them, you cannot do that. You cannot put these two together. Even though they have a common denominator, you can only multiply on that. The only way that you could combine them is if this was the square root of 2 and this was the square root of 2, and it's not. And there's nothing in there that could actually factor out. So this one here, if we get that, we could distribute this. And you would get the square root of 2 plus the square root of 6 all over 4 is your answer. Or you could rewrite it as negative square root of 2 minus square root of 6 all over 4. Either one would be correct. And so we have that. Okay, so let's do a proof. Well, before we do that, let's say that we have one of the other ones. So let's say I have the cosecant of negative 15 degrees. If I have that, again, it's an odd function because this here is the same thing as 1 over the sine of negative 15 degrees. So if you want to use that, you could, and then just work through it the same way, except for everything's going to be over 1. So you could do the same thing on there. Or you could do the cosecant and use the left-hand rule and the cosecant on there. And so you could change, it's 15 degrees, so you could figure out what angles could work to make that equivalent. So you could either use the cosecant and do it with the left-hand rule for cosecant, or you could rewrite it as 1 over sine over negative 15 and then solve from there. Okay, let's do some proofs here. So let me see. So any proof that you want to do is, let's say that we have the sine of 2x, sine of 3x plus cosine of 2x, cosine of 3x. So this one here is just going backwards. So here's the expanded version. So if we go back to look at these identities, what we're given now is we're given this part right here. So we're given like this part right there, and we need to get back to this part right here. So we're given the expanded version and we need to collapse it into one single one on there. So we have to figure out which one of these three is actually given to us. So when I look at that, I have here sine of the first angle, sine of the second angle, and then cosine of the first angle, cosine of the second angle. The only one that actually does that, even though it's not in the right order, is the cosine function. So I want to go back over here and look at that. So see how it's cosine, cosine, sine, sine, cosine, cosine, sine, sine, and it's being added. So if it's added, we know it's going to be the opposite. So what this one actually becomes, because they're being added and cosine is always the opposite, is that this one becomes the cosine, this becomes the cosine of 2x minus 3x, because that's the second angle in which it's written on there. And so that becomes the cosine of negative x. But we know that cosine is an even function, so the angle is going to be cosine of x, and that is your answer. And let's do one more. And so if we have the sine of A minus the sine of angle B, quantity squared, plus the cosine of A minus the cosine of B, quantity squared minus 2, what do we get? Well, this is algebra, and you have to expand it, and you're going to get a lot of stuff on there. So you're going to get sine squared of A minus 2 sine A sine B plus sine squared B plus cosine, that's this one now, squared A, minus 2 cosine A cosine B plus cosine B minus 2. So when you have this, now you have to like do combine like terms, try to figure out. Notice how we have some things here. So notice how we have this part right here. And so that's the Pythagorean theorem there. And then we have this one right here. So we know that's the Pythagorean theorem. So we get a 1 here and a 1 there. And so that one and that one are going to cancel with this 2. So that's going to cancel there. So 1 plus 1 minus 2. So that's going to cancel. And so now we're going to be left with, we're going to have negative 2 sine A sine B minus 2 cosine A cosine B. And so that's what we get because those cancel on there. And so then when we have this, I could factor out a negative 2. And that gives the sine A sine B plus cosine A cosine B. And we're back to the cosine, right? And so now we have that it's going to be negative 2 cosine A minus B. And that is our answer. Very good. All right. Good job.